Hi, we have briefly learned the correspondence analysis in week 4. Because we deal with variables measured in nominal scale quite frequently, the correspondence analysis should be useful and practical. But in my personal experience, correspondence analysis is not frequently used as much as it deserves. So let's learn about how we can practically apply this technique to a design research. You have seen this slide in week 4. At the time, we were learning chi-square test for independence. The issue here is related to the relationship between region and political attitude. As the map in background explicitly illustrates, it is easy to find that eastern part is highly advocating the right party, whereas the western part is toward left party. So they are more progressive. For a chi-square analysis, the frequency of at least 80% of cells in the cross-tabulation should exceed 5. In this table, we see that there are 2 cells, this and this, whose frequencies are smaller than 5. But 2 cells out of 15 cells is less than 20%. So more than 80% of cells in this table have frequency of larger than 5. Therefore, the frequency data are adequate for performing a chi-square test for independency. You calculate the chi-square value by hand or using an Excel or in SPSS. In this video, I'll demonstrate how we assign weight values for each cell in order to conduct a chi-square test for independency in SPSS when we have the data like this table. I opened a new datasheet in SPSS, and let me show you how to create the data table to perform a chi-square test for independency when we have already organized the data like this table. Actually, we have 3 types of information here. The first 2 are indicating the row information and the column information. Here, the row information is about political attitude, and the column information is about the regional division. So the first variable will be political attitude, and 1 for conservative, 2 for neutral, 3 for progressive. And we don't need decimal point because they are different categories. And as second variable, we create region variable, and this also doesn't need to have decimal points. And the first one and the one can be central Seoul. So we assigned each level with the regional information. And as a third variable, we create the frequency. Actually, that corresponds to weight of each cell. So let's name this as a frequency. And we don't need any decimal points either. So here, I have created 3 variables, and for conservative central soul, we have frequency of 25, and conservative peripheral soul, we have frequency of 25. So like this, the information presented in this cross tabulation is now reorganized in terms of 3 variables. And then you assign the weight to frequency variable. How you can do is data and weight case. You select the frequency and you appoint this variable as the weight. Alright, then you perform a chi-square analysis, descriptive statistics, and cross-tabulation for rows, political attitude, and for column, regional division, and for statistical value, we click chi-square and continue, and then OK. So here, actually this tabulation corresponds to this table exactly the same, and it should be. And based on this data, SPSS calculated the chi-square value, which is resulted this amount, and the degree of freedom is 8 because 2 by 4 is calculated. And with regard to the degree of freedom 8, this chi-square value is a lot bigger than the threshold. So the p-value, which is calculated based on this chi-square score, is smaller than 0.005. And therefore, we can conclude that there is a dependency between region and political attitude, which indicates that depending on the regional division, there exists different political attitude. And for the correspondence analysis, we should have the dependency between 2 variables. And this data support that there exists a relationship between region and political attitude. And consequently, we can draw a 2-dimensional coordinate and where we can position the 5 levels or 5 categories of a region overlapped with 3 categories of political attitude. For the correspondence analysis, you click Analysis, Dimension Reduction, and Correspondence Analysis. And for the row, political attitude. For the region, for the column, we assign the region, and we also need to assign the range. For political attitude, we had 3 categories, and we take all 3. And for region, we take all 5. In fact, actually, there is option to analyze chi-square test directly from correspondence analysis. From next time, you can directly use this analysis also to see where there is a dependency between 2 variables. Let's click OK. Alright, here I have obtained a two-dimensional matrix where the 5 levels of a region and 3 levels of a political attitude, progressive, neutral, conservative, are arrayed or are plotted in a two-dimensional space. And it is up to you how to label each of both dimensions. It is like you can label the factors in factor analysis. So here you also can generate different ideas to characterize the horizontal direction and the vertical direction. As shown with an example about region and political attitude, correspondence analysis is used in order to visualize the dependency of frequency. And this displays the categorical variable in a space which maps their association in 2 or more dimensions. We frequently use a two-dimensional space because of a simply practical reason. The fact that correspondence analysis has so many synonyms provides evidence actually that it is a lot practical for marketing and social science studies. Remember that correspondence analysis is another name of visualization of a chi-square test for independence. Then let's consider this example. We all share these data. Among the 20 adjectives, I selected these 4, such as fresh, flamboyant, classic, and comfortable, just because these 4 seem to describe quite different aspects of product design. But my selection is just a random choice, and I'm showing you an example. The task here is to allocate the following 12 products, and the rule is that their position should be determined in relation with their scores on each adjective. When we consider the average scores in this table as frequency, we can apply the chi-square test for independence, and the correspondence analysis can be also applicable. In this case, we have now 2 nominal variables. One is product category and the other is characteristics. The product category variable has 12 levels and characteristics variable has 4 levels. I am mentioning this in order to help you to understand the data correctly. But already you're very clear with that. And before we conduct chi-square test, actually we have a problem. The scores are averaged values measured on a 5-point Likert scale by 30 people. So all cells actually contain the scores smaller than 5. Therefore, we need to convert these small numbers into frequency data in a proper way. There is no single answer. My idea to inflate the average scores is to multiply the scores by the number of a sample size. But I'm not yet sure whether that's a very clever way. The quiz number 3 here is asking you what your idea is regarding the conversion from the average scores into the frequency data to perform the chi-square test for independence. And in class, based on your idea about the answer 3 in the previous page, you will conduct the correspondence analysis and you will draw a two-dimensional coordinate which contains 4 adjectives and the 12 products. It's not necessary to include all 12 products. You can select very different couple of products out of 12. That's also allowed. Now I am in SPSS to demonstrate you how to draw the map using my own idea to convert the average scores into the frequency data. I said that's a not very clever way, I'm sure that you have a much better idea to how to convert these mean scores into the frequency data that really indicate the frequency characteristics of each combination. So here, instead of the mean score, let me create one more variable by computing this. So I would name this as by multiply by 30, and that will be calculated through this. So I'm multiplying mean score by 30. So a new variable is created, and this will be assigned as the weight variable. Weight. Right. So using these two and then this, I'm going to perform the correspondence analysis. Here, adjective and product, and for adjective I take all, so 4, and the product 1 to 12. Okay, so here you go, the result. These two variables have a statistical significance with dependency here, and then this chart shows you the internal relationship between the 4 levels of adjective and 12 different products. So product number 5 is the closest one to comfortable. Let's see what product 5 is. Product number 5 is this. Well, I agree that this should have characteristics of being comfortable, and indeed it has the highest score with regard to comfortable. So the map is quite practical to overview where the 4 adjectives are positioned in relation with the 12 products, or in other words, where the 12 products are positioned in relation with their characteristics of each adjective.